The chainsaw. A wonderfully simple concept that gets the job done. A gasoline-powered two-stroke engine drives a chain outfitted with sharp metal teeth. An 18-inch chainsaw running at 3 horsepower will easily cut all the timber you want and save a lot of sweat. Could a similar concept work for cutting through much harder material, like solid bedrock? What would such a machine look like? It looks like this, the giant rock-cutting machine known as a chain trencher. And the biggest chain trencher in the world is the Aztec Underground 1860 HD.
The Aztec Underground 1860 HD chain trencher. Total weight, 350,000 pounds. Engines, 2 Caterpillar diesels, one at 1,200 horsepower, the other at 300. Fuel consumption, 75 gallons per hour. Maximum chain length, 35 feet.
A chain trencher is a specially designed piece of construction equipment made specifically for excavating hard rock and digging it out in a trench for laying in utilities.
For exceptionally deep or long trenches, contractors call on the 1860.
This machine can go up to 30 feet deep, where currently right now we have a machine going to Israel that's going to cut 50 feet deep. The 1860 I cut in Africa. We cut a job there, and we cut 8 feet wide, 12 feet deep for a 72-inch gas line that went all the way through Morocco. That job took us 1.5 years to cut it.
There are only 9 1860s in the world, and people generally remember the first time they saw one.
When you actually see one of these machines in production in hard rock, you can actually feel the ground vibrate as it is ripping the ground apart below it.
It shakes quite a bit. There's 2 main engines in there, and with all that vibration, that chain digging up the earth, it just bounces all around.
6 of the world's 9 1860s are owned by H.L. Chapman Pipeline Construction in Texas, where hard bedrock sits just inches under the surface across much of the state. Definitely a job for one of the world's biggest machines. Although it's not difficult to spot the business end of a chain trencher, less obvious is the fact that the digging boom is actually the rear of the machine. The sheer weight of the front end, engines, treads, and a giant gas tank helps the chain dig in.
So you get penetration and production. Weight and horsepower equal production in these machines.
The 1,200 horsepower Caterpillar 3512, easily the larger of the 2 engines, is dedicated to powering the cutting chain only. The chain is mechanically, not hydraulically driven.
It's very important to get all the power to the ground, and we found that we can do that much more efficiently with the mechanical drive trencher system.
A separate 300 horsepower engine drives the hydraulically powered crawler tracks, which move the mighty machine along at speeds up to
approximately 1 mile per hour. So the machine does move very slow, and then in the work condition, when you're actually digging a trench, that speed may be as slow as 2 or 3 feet per minute to 10 or 15 feet per minute. The track system is designed more for torque and pulling power.
The second engine also powers various hydraulic devices.
Basically, we're controlling our conveyor, the shift and the rotation of our conveyor, the raise and lowering of the boom, and then our track drives. And then, of course, the heart of the machine, the head shaft where the digging boom attaches for actually excavating the rock. If you're familiar with the chainsaw, this is essentially the screw that you would use to adjust the chain on your chainsaw. However, our boom is significantly longer than the bar on a typical chainsaw. Because of the extra weight, we use 1 8-inch grease cylinder on either side of the boom. As you apply pressure, it slides the whole boom out, and then we apply some shims to maintain that distance.
Despite their striking resemblance, to call these machines giant chainsaws doesn't really do them justice. Chain trenchers are a highly specialized and extremely precise class of machinery, beginning with the cutting chain itself. The carbide steel teeth are arranged for maximum punishment to the rock surface.
This is our standard chevron pattern. It's on all our machines. This is the #1 strike tooth. What this does is it goes through, it actually makes a mark into the rock. As the second tooth comes in, it strikes here. This little area right here will frack out and become the chip. These teeth are self-sharpening. They actually will keep the point on the tooth, which helps the longevity of the tooth, which helps keep costs down for the contractor.
The steady striking pattern, like an endless 1-2 punch, pounds away at the rock. Ideally, it also results in large, consistent chips, which can then be used as trench lining material.
This is typical size of smaller trenchers. This is the chips that we want to get because this means production.
Precision is also key in controlling the chain trencher's path. Without it, such a powerful machine operating in often sensitive underground environments could lead to disaster.
You may have an existing gas line, water utilities that are already in the ground, and the contractor has to come back and lay a new line in the same right-of-way, and he may only have a couple of feet, sometimes less clearance between existing live wires or gas line.
A laser-guided positioning system directs the operator as he rips through the rock, keeping the trencher level and its path ramrod straight.
We've got a pole that sits on top of the boom, and then we've got a receiver on the inside. That allows me to know if I'm up or down. I've got 3 lights in there. The green is dead on. I've got an upper yellow and a lower yellow. They are within 2/10.
The accuracy of the 1860 chain trencher also makes the serious business of cutting rock safer.
This bore pit has the square walls because of the trencher cutting ability. This enables safety. This keeps the personnel down in the pit from big rocks falling on their head, and that hurts.
Chain trenchers fit in perfectly in Texas, where everything is, as they say, bigger. But these machines and the men who maintain them are world travelers.
We have machines running throughout the Middle East, Europe, pretty much throughout the entire world. If there's rock, we typically have a machine there.
But it takes more than one type of big machine to make rock do what we want. And sometimes, we want it crushed. To disassemble and move an 1860 chain trencher, including the tracks and boom, requires 2 90-ton cranes and 7 tractor trailers. The Earth is quite literally made out of rock, and so is much of civilization. At Vulcan Materials Quarry in Manassas, Virginia, ton after ton of this basic building block is blasted out of the Earth's surface and processed into aggregates suitable for everything from roadways to prefab concrete walls.
Most of it serves the local market for concrete, asphalt, cinder blocks. We use it for road base, for beds, for bridge building, for driveways for people's houses. The industry says that for every person in the area, you have to supply 10 to 12 tons of rock per year.
But it's no mean feat turning 4-foot-wide volcanic diabase boulders into tiny uniform stones. It's a job that calls for some very big machines, like the one housed in this 10-story structure, built to deal with the fact that rock doesn't come in convenient sizes. Rock crushers.
The Metso Minerals 4265 Superior Gyratory Crusher. Total weight, 264,000 pounds. Height, 10 stories. Motor, 500 horsepower electric. Diet, 2,557 tons of stone per hour.
The 4265 is known as a gyratory crusher because of the motion that actually does the crushing. The relentless back and forth gyration that compresses rock against the chamber walls.
To give you a visualization, this crusher is just a giant mechanicalized nut cracker. That's the same principle. When you have 2 surfaces, hard surfaces closing together with a soft surface in the center. In this case, believe it or not, the rock is a soft surface. So it's 2 mechanically advantaged metal pieces coming together and compressing that rock, and the rock breaks down to a smaller size.
The process begins in the control booth that sits atop the crusher. where the operator has a front and center view of each 100-ton load as it's fed into the crusher's mouth. Water spray keeps the dust constantly under control.
All of our crushers are designed to work at a choke-fed position. It's because the rocks on top of the crusher help push down the rocks through the crushing chamber, and the rocks will actually crush against themselves. That's called rock-and-rock comminution, and it actually does a better job of crushing size materials.
Primary crushers such as this one can accept rocks up to 3.5 feet in diameter. Operator Pete Huff uses a hydraulic hammer to reduce anything bigger. At the core of the crusher is a solid steel shaft, up to 26 feet long. The cone-shaped mantle threaded to the shaft provides the crushing surface. The shaft and mantle were each forged as a single piece of steel.
The mantle itself, the main shaft, weighs in excess of 52,000 pounds.
This giant nutcracker is powered by a 500 horsepower electric motor. The motor drives a horizontal pinion shaft connected to a large crown gear, which causes the giant vertical main shaft to spin. The main shaft sits in a housing known as an eccentric due to its asymmetrical shape. As the main shaft rotates, it shoves the crushing mantle back and forth in an eccentric pattern, 170 times per minute against the chamber walls. The rocks don't stand a chance. The crushing mantle would be nothing without ultra-strong chamber walls.
The castings on this machine are cast steel. They're heavy ribbed cast steel, very strong chambers. They are wear-plated, protected with either a manganese concaves or a steel alloy concaves.
2 stories down from the control room, the crushing is in full swing.
Right now you're hearing the rocks being crushed against this outer chamber here, which is the top shell. This section right here is the top shell with the heavy ribs that support all the crushing forces. From this joint below, it's called the bottom shell, and that's where all the mechanics of the crusher are. The eccentric bushing, the bottom shell bushing, the eccentric, and below that is a main shaft position system, which raises and lowers the main shaft.
The greatly reduced stone emerges below.
You can see the size difference between the back of the truck and what's coming off that conveyor. That's how much it reduces that rock through that first stage.
This highly efficient method, known as compression crushing, has played a key role in history.
The first patented compression crusher was developed by a gentleman by the name of Eli Whitney Blake. Back in 1858, he held his first patent. He was actually the nephew of Eli Whitney, the inventor of the cotton gin. Eli Whitney Blake was challenged by the town commissioners to develop a crusher or some type of device to reduce stone in order to make macadam for a 2-mile stretch of highway. It took him 5 years to create this machine, which features 1 stationary jaw die, 1 opposing, turned in an eccentric motion. This became the first compression crushing, and the Blake-style crusher is still in production today.
In the late 19th century, rock crushers would prove invaluable in laying roads across a growing nation and in extracting precious metals out of giant blocks of stone. Nevada's legendary Comstock lode pumped out wealth at an unprecedented rate, thanks to mechanical crushers. A major innovation in giant crushing machines came in the 1920s with the Simon's type, or cone crusher. Unlike a traditional gyratory crusher, the shaft on a cone crusher isn't supported at the top. This gives the crushing mantle more freedom of movement and twice as much horizontal throw. Today, Mezzo Minerals makes the world's largest cone crusher, a 340,000-pound, 1,000-horsepower behemoth known as the MP1000, which also happens to reside at Vulcan's Manassas, Virginia quarry.
The MP1000, the largest machine of its type ever built, the most highly technically advanced machine, and it's exciting to see.
The MP1000 is the secondary crusher at the quarry. The stone already reduced by the gyratory has made its journey over on a conveyor belt and awaits a further crushing. The rapid throw of the mantle pulverizes the rock against the steel cone-shaped bowl liner.
This is a bowl liner. This bowl liner fits into the upper portion of the machine. The bowl liner is a manganese wear surface. This wear surface is actually what the rock is impacting against. As the machine gyrates from one motion to another, as the material passes through, the rock then is reduced, falls through, and then moves to the opposing side.
After exiting the mighty MP1000, the stone can move to a third or even fourth crusher, depending on the desired product. With multiple crushers and screens, Vulcan Materials produces crushed stone ranging from large rocks suitable for flood control to sand that might end up in concrete. Crushed stone is the result of power and precision. That's a combination that also works down on the farm. Get ready for a high-tech harvest and the world's biggest combine. For over 40 years, Vulcan Materials has been quarrying up to 25,000 tons of stone per day from a single pit that has grown to encompass 145 acres.